We're excited to talk today about unit testing for Alexa skills. We actually did one of these webinars in January. And since then, we've really added a lot to our tooling. So if you joined us then, I think you'll see that there's a lot of new stuff that we're very excited about. And if you're new to this, welcome as well. We are certainly eager to talk about unit testing and testing in general for Alexa and voice apps. So just for introductions, I am John Kelvie. I am the CEO and founder of Bespoken. I'm joined on this by Bo Schrader, who heads up our marketing, Ivan Perez, who leads our customer success, and Fiorella Casavilca, who does sales for us. They're all in the chat window there, so you can interact with them through the webinar software. And it's just a bit of background on us. We provide monitoring and testing tools for voice apps. We are a recognized vendor of Amazon and Google, and we have over 1,000 apps that we're monitoring, as well as more than 2,500 developers. And we have a long history with speech recognition and AI. So actually before Bespoken, I was doing interactive audio ads. And they were actually ads that use speech recognition. And in the process of doing that, we learned a heck of a lot about doing speech recognition at scale. And I would say sort of an interesting observation we had there was even when we were the ones responsible for building the speech recognition engine, probably 90 to 95% of our time, engineering-wise, was actually spent on testing it, as opposed to actually coding it. So testing it's a challenge. There's some particular things about these platforms that make it challenging, and it's just generally a challenge for AI, and we're really happy to be able to help with that and bring the experience that we have with it to bear here with Bespoken. So with that, we're just going to give you a brief overview of testing and monitoring. Some of you guys that have joined us before, this will look like review, but we do just like to kind of level set. There's a few different things that we do, and there's a way in which we approach building for voice apps that we like to tell people about. So first off, on the left-hand side here, these are just some generally interesting stats about Alexa and voice app development and development in general. One thing in particular I would highlight, we have the cost of bugs, this little chart here. And what you see is that the cost of a bug that's found during the design phase, it's 1/100th of one that's found during production. And that's a big incentive to do testing and to do it early, because if you catch issues early, they become far less expensive. They involve less people, they involve less infrastructure, deployments and whatnot, less confusion. You massively cut down on the cost of issues by catching issues early. And so how do you do that when you're talking about voice apps? Well, we have this layer cake that we use over here on the right-hand side to explain our approach. And the first part of it is manual testing. We see that as a critical step, and we think most people are doing that. But we don't think that you should stop there by any means. Automated unit testing is very important. That's focused on improving code quality. That's what we're going to be talking about more today. End-to-end testing is not so much about code quality as testing the app as a whole, and in particular, testing the interaction model and some of the AI aspects of it. And then lastly, the continuous testing, that's actually, we refer to that also as monitoring. But that's about testing your voice app once it actually goes live. So once you have it in production, we have some great techniques for testing it on an ongoing basis. And one thing I should mention is we've actually done webinars on all these subjects. those webinars are available on YouTube. We'll provide a link to that in this presentation, which we'll also provide to you. And you can go and look at those, and we'll also be doing future discussions on each of these topics. We've kind of gotten into now a cycle doing these webinars. We do them on a monthly basis, and we go through the unit testing, the end-to-end testing, and the continuous testing. We think all of them are very, very helpful subjects and very useful for anyone that is developing voice apps and skills. So manual testing, I think everybody sort of knows what this is. You can do this with an actual device. You can do it with a simulated device, such as the Echo Sim, or you have the Reverb app that's provided by Rain. Additionally, there's the Alexa testing console. We think that that's a fantastic tool for doing this. And
I don't know that.
I should have muted my device there. And then we also have our own tools for manual testing. We would highlight that if you're using our tools, you can actually run your tests locally. So you don't have to do any sort of deployment. You can just be testing your code locally on your machine, which is a very helpful thing. And in terms of actually just doing all that testing locally, that's just generally something that we encourage people to do and that we enable with our tooling, especially for the manual testing as well as for the unit testing. And so overall, what are you trying to achieve by doing the unit testing? Well, as you're doing development, it's extraordinarily helpful for finding bugs and trying out your code as you're working on it. It's really focused on testing the code in isolation. So when we're doing unit testing, we try to remove dependencies on other resources, whether it be DynamoDB, AVS itself. As much as possible, you want to really simplify those things and focus on the code itself. And so the tooling that we provide is very helpful for that. In addition, code coverage is an integral part, we would say, of unit testing. If you set up your unit tests, you have them running well, it's then very easy to establish your code coverage, which you can be running locally. We're going to show you how to do that. And then also you can pretty easily leverage tools like CodeCov that are hosted utilities. And if you upload your information there, you don't just get some pretty graphs around what's happening with your code over time and your code quality over time, but you can also dig through and see what's happening with different pieces of it, where there's problem areas. There's a lot of analysis that tooling like CodeCov can provide that's very helpful for a developer. And we're going to go into more detail on all that in a moment. I'm just going to check our chat window here real quick. All right, just saw a couple questions there. So the other side of testing, which what we think is really critical for testing, is to see how much it can help you during these phases. And so the way we refer to it is that we say that it's actually a superpower that you can get. And part of this is really, it goes back to the idea that there's such a thing as a 10x developer. I've always found that concept as a developer myself is sort of interesting. It's sort of a mythological creature. But our theory about it is that to get to sort of a 10x level of productivity as a developer or 10x quality, actually the way in which it's achieved is not by suddenly becoming much smarter or more knowledgeable, but instead to become more effective using tools that are available. And with unit testing tools, we see these as something that can vastly improve somebody's productivity. So if you take advantage of tools that we provide, when you're talking about the unit testing, end-to-end testing, you can troubleshoot problems much faster. And so an example with that on the unit testing side is if you set up good unit testing scripts like the ones that we'll show you, you can actually jump to the 5th step in a sequence with a particular state configured. And that makes a really big difference. If you're actually doing the same sort of test manually with the device, that can take several minutes and be error prone. You may sort of miss the moment, if you're just doing console.log and working slowly through manual steps. It can take minutes or hours to solve problems that you can actually troubleshoot and cycle through in a matter of seconds or minutes if you're using automated unit tests. So that's a really helpful thing. Additionally, when you're doing unit testing, you're doing everything locally, that's going to allow you to do your cycles a lot faster. If you're doing deployments out to the cloud every time, deploying your skill to the console every time that you want to test it, that's a much slower process. I mean, again, I don't want to overstate the benefits here, but you really can go 10 times faster or more. Another benefit that we see to this one is maybe a little bit more subtle, but if you're building well-tested components, you can actually combine those together in a way that it allows you to build things that are more complex than if you build it as one giant component. That's something as a software developer, it's sort of like you're standing on your own shoulders to create works that can be sort of ingenious. It's an amazing part of software, and unit testing is really helpful for that. By the same token, end-to-end testing can give QA people some of the same benefits. If you're working through testing a complex skill with a complex interaction model, if you use our end-to-end testing tools or other end-to-end testing tools, you can save yourself a huge amount of manual effort. And writing test scripts, we've done other webinars on this, it can be done almost as quickly as you can interact with the device, and then you have this artifact that you can use on an ongoing basis. So the end-to-end testing is extremely helpful. It is the other side of unit testing in the way that we look at it, because you're not just trying to test your code in isolation. Instead, you're trying to test the system as a whole, and in particular, focus on some of the aspects around speech recognition and natural language processing. And just a couple considerations that we just mentioned with the end-to-end testing and testing in general for voice apps. These are constantly evolving. Part of what's new and really exciting about this and the whole space with Alexa is that you are actually working on an AI-based operating system. But the other side of that is that it is actually changing over time. There's a constant evolution to it because it's based on machine learning. And that's something that it provides more of an impetus to do testing and to be focusing on quality even after you're done with your development and test phase. In addition to that, you have lots of different languages and locales. Internationalization and localization are always a challenge, but when voice is your primary input, it becomes even more so. And finally, you have multiple different platforms out there. We do focus on Alexa and Google, but with the different platforms, when you're talking about Siri, there's supposedly a Facebook platform that's coming out. Ensuring that you have consistent behavior across those platforms is something that is definitely a concern. So those are all things that we try to address in our tooling. And with that, we're going to talk about unit testing in more depth. And in particular, we have some new stuff that we want to show you, and that's our test scripting for unit tests. So I'm going to exit the presentation here, and actually the first thing I'm going to show you guys here is our new documentation site. We've been working on putting this together, and it's really meant to consolidate an entire approach to how one does testing and monitoring for voice. And then what we're focused on today is the unit testing piece here. And there are links to this in the presentation that we're going to provide. But if you go to this site, particularly if you look at this Getting Started guide, it's going to review a lot of the things that I go through. And you can come here and you can learn all about these pieces. And so what does a unit test look like? So I'm going to start with the simplest possible unit test that I can. And let me zoom this in here. Sorry, the zooming is always the hardest part of these presentations for me. All right, well, hopefully you can see this okay. My text is not getting any larger here when I click on it. But this is a really simple test that is put together using our test scripting language. This test scripting language is based on YAML, and the tests are based around the idea that you're going to have an input, and then you're going to have an expected response that you can write one or many assertions against. So this first test, this is about as simple as you get. And we're actually looking at the example get fact skill here from Amazon. So we're also looking at a really simple test. So in this case, we have a little bit of metadata about the test. And then we have this first interaction, which is just saying, give me a fact. And then this is an assertion, which is just saying, here's your fact is what we're expecting in reply. And it's implied in this that it's just doing a partial match. So the actual response that comes back is longer than this, but we're just testing against the first part there. So that's a very simple test to construct. Slightly more complex here. We're going to say, give me a fact. And here, we actually are asserting against a couple different fields. So we're going to check the prompt, which is going to automatically pull out the information in either the SSML or the text. So this is just sort of the shorthand property that you can reference from the actual skill response. And here we're actually using a regular expression. So you can write these tests using regular expressions. In addition, you can test things, other properties of the response, such as the card title. So here we check the response, we check the card title, and we see if it's all working correctly. And then this last one is showing us testing a different intent. So this is a really straightforward test, very easy to write. And to run it, we go over here, and I'm just going to run this test, and I do that by running the command bst test and then I say simple, which is going to run just tests with the word, test files with the word simple. And so I went ahead and I ran that, and you can see each of the tests, the output here. You get a check mark next to each of the interactions that happened, as well as the information about which one was run, and then code coverage information down here. And so all our tests ran without any issue, which is great. Our code coverage is 66%, which is, that's okay. Now we have a deeper, more exhaustive test for this skill. And you'll see it's basically the same structure, but we have several more test cases. The way in which we're writing assertions is a little bit different. We're not using that shorthand that says prompt. Instead, we're referencing the full JSON element that comes back in the reply. We're testing a number of different fields. In this third test here, we're actually running through a sequence of interactions. So it's launch, help, and exit. And we're even testing things like on the response card, we're ensuring that there's not a response. So we say that we test and say that the response card is in fact undefined. And so if we want to run these tests all together, we just say BST test. And in this case, it actually ran both of our test suites. And now our code coverage is up to 92%, which is really cool. And if we want to look at that in more depth, when we run these tests, this coverage directory is automatically generated. We can double click on this index.html, and then we see what the code coverage is for each of the files. Now, this is a really simple skill, so there's actually just one file here. And here we can see which lines are covered. This notation here means how many times the code is executed. Excuse me. And we can see here that we do have one small piece of code that's actually not covered, and that's highlighted in red. And so our error handler is not called. So we haven't figured out in the skill a way to actually trigger the error handler. We could probably come up with a test for that, but other than that, 92% coverage is excellent. That's going to give us a lot of confidence that our skill is working correctly. Now, just in general, one of the sort of principles around code coverage, if you write tests for your skills or your apps, that's not going to guarantee that it's working. But a rule of thumb that a lot of people operate on is if you haven't written a test for it, you should just assume that it's not working. That may seem like kind of a cynical view or approach towards programming, but I think most of us know that if you haven't tried something out, if you haven't tested it, there is a very good likelihood that it won't work in the way that you want. So having the code coverage there, knowing that all your lines of code are being executed, or at least the vast majority of them are, it's going to give you a lot more confidence that things are working correctly. And if somebody does happen to find a bug, you've got the infrastructure in place that you can quickly, one, reproduce it, and then two, add a fix, and add a fix that ensures it doesn't get broken in the future. And I see that there's a question about account linking. I'm actually going to come to how we handle that in just a moment. But so, this is a really basic test suite, that's set up to execute our skill, produce the code coverage. It's runnable very easily through this command line here. And it really doesn't take long to set up these tests at all. We have a lot of sample projects that are out there that you can use for getting started. We've tried with this YAML syntax, which we actually first introduced for our end-to-end testing. We've brought that for the unit testing as well, because we want to make it as easy as possible for people to create these tests. So this is our getting started project, and actually the question around how to handle account linking, that's actually a great segue to the next thing I wanted to show you, which is tests that we set up for the address API example project. This is again a sample project that's from Amazon. We think it's a neat one. It's useful for showing you how to use the address API, the sample project. And we think this is also helpful for showing how you would do something that's a little bit more complex. And in particular, in this case, we're emulating account linking as well as utilizing the address API. And so how do we do that? So one, we have this element here, the configuration. This is metadata about the test. And you can put in information like what the locale is. There's actually a few different properties that you can set. But of particular interest for us in this case is you can set an address. And what this does, one, it treats it as somebody has provided it sets up the state as if somebody has given the permission for the address API. And two, it defines the payload that the address API is going to return with. And so you can configure this with these fields that actually come from the address API. So this is the actual documentation for it. There's the country, region, postal code permission, in which case you just get back these fields. And if you want to emulate that, you just set those fields. And then there's the full address. And that's what the payload looks like. And so when you set these values, this is going to tell our skill tester to automatically return this when a call is made to the address API. And so how do we do this? Well, we actually use a mocking tool called knock. And knock is really great in that it intercepts calls to certain URLs, and it sees that call to, say, the address API, and instead of actually calling the address API, instead what it does, it actually comes back, it catches it before it goes out, that HTTP call, and it just returns this value, this payload. And so that approach to mocking is something that we use, whether you're talking about the address API, we use that for Dynamo. We're adding that for the monetization API. We think that's a really helpful thing for unit testing, and that goes to the point about how you want to be able to easily set up your tests so that you don't have external dependencies. That's going to allow you to create tests that are much more reliable, as well as tests that are going to run very, very quickly. If you're making lots of external calls, that's going to slow things down. And just to quickly show what we would do in the case of account linking, you can actually set an account token. And that's then going to be inserted into the request payload that's sent. And then in turn, you can either automatically mock that out, what the reply is based on seeing a particular account token, or you can have it actually go to your actual database. We would tend to advise people to use mocks, but if you have actual values in the database that you want to use, you can ensure that it sets that right account setting in this configuration object. So in this case, with our address API example, so we actually have a few different tests, and these different test files, we've set them up because each one has slightly different configuration data. And so we're trying to cover different aspects of the address API. So we have a case in which we're just providing the postal code information, one in which there's no device ID. There's no device ID that's going to correspond to somebody not having given permissions. One in which somebody's given permission, but there's no address. So that would be a user who has not filled out their account completely. And then test for the full address. So we can go over here to the command line for this project, and we go ahead and we say BST test here. And so this is run through all those test suites. Again, we have a very high level of code coverage. And we've actually tested some more complex scenarios. So if we go and look at the code coverage for this project, here we are. So you can see we're testing a lot of different conditions. So for example, this line here, we're testing that line where address line 1 equals null with this test. So we've explicitly set that value to null. And this is where the sort of the magic of the mocks that we have comes into play. But we're just using the Alexa SDK, and it's making a call to get the address.
I'm not sure about that.
We have our await here, gets back the full address. But this is essentially returning instantaneously because instead of actually calling the address API, instead our mock is intercepting the call and returning the address. And specifically for this test, it's returning it with address line 1 set to null. And so this interaction, we say launch, and we don't even really look at the response. We've tested that elsewhere. And then the next step is we ask, what's my address? And then we look to make sure that it actually comes back with this reply. So let's say that we had an error in our test. Let's see what that looks like. So I changed my expected response, and now I'm running it again. And we get a test that failed. And when it fails, we get this very nice output. I'd like to take credit for doing all this work to generate this output, but we actually built this tool on top of the Jest framework, which is a really great unit testing framework from Facebook. And it provides this detailed information about what happened, as well as highlights which test it was, or the line within the test that was the problem. Now, in this case, I mean, this is a pretty easy error to fix. I mean, we're looking at the expected and the received value, and we can see that, essentially it's a typo in our test. But what if this was a real problem that we wanted to debug? So this goes back to what some of our superpowers are. By using a localized unit testing framework like this, we can actually go in here, and I'm using WebStorm, but you can do this in other IDEs just as easily. We can set up a configuration, and the configuration basically is just telling it, okay, go ahead and run the BST test command in this directory. So if I go ahead and I click the debug icon there, it's going to run through my tests, and then it's going to pause when it hits this line. And let's say we get down here. And I can see the response that's coming back. And let's say we wanted to focus this. This is actually going to run through all the tests by running it in this way. But if we want to focus on fixing just one test in particular, I put in an application parameter of postal, which is going to narrow down to just that postal test. And I can actually put, there's only one test in this file, but let's say if I had many tests, if I put this test.only, it's going to ensure that of the tests in this suite, in this file, only this one is run. And so in that way, I can quickly isolate to one particular test. So I go ahead and I say run again, and I know that just this test is going to be run. When you're debugging things, that's really helpful. So again, I get it's going to stop at the same breakpoint. I can see my address. I can see the reply that comes back. And I get down here and I see, oh, it hit this line of code. Now, I'm not surprised by this, but if I had a real bug that I was working through, I might be surprised by it, and it's useful to see that that's the path that it's gone down, that I can look at this detailed state of all the different variables. It's very easy to dig through this and quickly debug and solve any problems that are going on. So this is really a fantastic tool that we encourage people to take advantage of. Now, for those of you that joined us previously, what you saw was actually the underlying componentry that we use for this. So we have, we still offer that. So I've shown you so far our YAML-based test scripting, but we still allow you to directly interact with our emulator. And I do say it's an emulator because what we're doing here is we're actually generating requests as if they're coming from Amazon, but it's not actually interacting with AVS or going through Amazon at all. That's what we do with our end-to-end testing, but for unit testing, it's using an emulator and it's just generating payloads as if it was coming from the actual device and service. And if you wanted to write tests programmatically, you can instantiate the emulator. You provide a handle to the Lambda that you're testing, handle to the interaction model, and you can just run through and write tests against that. This is really easy. By adding our test scripting syntax, we're trying to make it even easier. In addition, one thing I would highlight, we're not going through it today, but that same syntax, we leverage that for our end-to-end tests. So we're consolidating or unifying the approach to testing, which we think is something that's useful. So you can sort of learn this one way to test and really use it for all the different bot testing and voice app testing that you do. So we're not going to spend a lot of time on this, but this is a neat thing to know that it's there and very useful. In addition to that, we have set up all these sample projects so that they're using continuous integration and code coverage. So how did we set up continuous integration for this? I mean, it's really simple. Once you've written your tests, in this case, we're using Travis, which is a popular continuous integration tool. And we have an install step, which is installing our tools. We install the code coverage executable. And then we run npm install. And that just makes sure that all our node modules are set up. That's the setup. And then the actual testing is just a matter of writing a script that says BST test, which you saw me running on a command line, and then running codecov, which automatically takes the coverage information and sends it to codecov. You can actually, if you have your own project and you set up tests in the way that we've shown you today, you could just cut and paste this script and you'll have your code coverage basically all set up. And with that, or your continuous integration all set up. And why do you want to do that? Well, every time after that you make changes and you push them to GitHub, it's going to actually run the test for those changes. So you can see Yvonne and I have been working on this for a little bit. We've been tweaking different things. We've done a good job so far. We've never broken the tests. But if you do break the tests and the code stops working, you're going to get a notification from Travis or whatever continuous integration tool that you use. And it's going to let you know that it's broken and you should fix it. And that's really helpful. In turn, it's also then really easy to tie into the code coverage tool. So I mentioned that earlier. Here we see our code coverage over time. We haven't improved it much. We started at a pretty high level at 88%, and it's gone up to 90, so that's good. And if we click on some of the files in the project, we're going to see information like I was showing you locally there. Oh, I'm in known address, but there's a lot of useful data here. It looks pretty similar to what you're seeing locally in that index.html under the coverage folder, but slightly different highlighting, maybe a little more readable. But then you get these nice graphs. This is going to highlight potential problem areas in your code. We have many different files. This is going to be useful. If we look at the audio player, this is, well, sorry, that's not. Well, most of these tests are actually for single files. But if you have multiple files, it's going to highlight where where the code coverage might not be as good. Like I said, you're going to see this history over time. And so that's all extremely helpful. And yeah, so I think that covers a lot of the basics here. I would just, before we go to questions, I would just mention again that this site, especially at Getting Started, is a really useful resource. This is going to guide you through a lot of what I've covered. And then in addition, it has nice links at the bottom here to these different sample projects. So we have the GetFacts, Address API, Hilo Game, audio player. You can look at the GitHub with the tests that are set up for it. You can look at Travis with continuous integration configured, and you can look at the code cub as well. So you can see how we've set this up for all these different projects, which we think is really a great resource. And so with that, let me jump over here. I'm going to stop sharing and happy to answer any questions around what we've shown. Yeah, so I see, how do you use values from the database? I mean, that's, I didn't go into our Dynamo project, but let me actually just share that real quick. So we take the same approach. If you're using Dynamo, especially automatically as it's used within the SDK, in order to mock that, it's really simple. And it's going to emulate as if you have a data store and an ongoing interaction, but it's actually just all running locally using mocks. So you say Dynamo : mock, and that configures the mocking. And then from there, it's going to automatically save the state for the user across all the calls within this test file. So this test, this is the high-low one. This is a good example. As we go through these different tests, you can see here at the end of the first test, games played equals 1. The second test, games played, is still equal to 1. That's because we didn't actually play a game. Test 3, here we go through another full game. And oh, look at this. Games played is 2. Ended session count is 3. And so these are different values that are being actually stored into Dynamo. Just using the SDK capabilities. And they're actually available for testing, and they're being successfully preserved across calls. But then the cool thing is you don't actually have to have Dynamo set up at all. This is, again, all done using our magical mocks. And once this test is completed, once this test file is all run, all that state goes away. And so if I set up another test file, I can call it, with a different user and different state, the Dynamo state is going to be completely reset. And so that's a really useful thing. And I see that there was an earlier question about the device address permission. I think I covered that, but if there are any more questions about it, please do go ahead and ask. I should also mention we have this nice banner. I'm sure you guys probably noticed this. We just had this created. We thought it was pretty neat. Yeah, and so using JSON objects and arrays in session attributes, can I just access them? Yeah, absolutely. So one thing I should highlight here, let me share my screen again. So each of these assertions, this is actually referencing different parts of the JSON. So if you had, and we use something called JSON path, which, I mean, we're not, these are pretty simple cases, but you can do very sophisticated stuff with JSON path for writing assertions. But if you had some deep JSON in here, you know, session attributes, my object, my property, my nested value, and let's even say this was a numeric value, you can write tests to say is greater than 2. I focused on really showing some of the more basic capabilities and sort of getting oriented to this. When you use this colon, that's an equals. You can also write equals like that. But you can use other operators like greater than, less than, greater than or equal to, not equal to. So you can write fairly complex assertions against any part of the JSON payload that's coming back. So that's another good question, Claire. Thoughts on testing voice recognition and matching slots. So today we are talking about unit testing. We don't, you know, none of this really has to do with how would you test the speech recognition or the interaction model. However, that is what our end-to-end testing is for. And like I mentioned, we have done other webinars on that. We also provide some links to that in this presentation that you can see. The end-to-end testing that we provide is really fantastic for testing the speech recognition. But it is much different. You know, with the unit testing, you're running everything locally. With the end-to-end testing, you have to have actually deployed out your skill. You have to have your interaction model all set up, and then you can run tests against that. And you can use the same approach for writing those tests, but the way in which it works is really, underneath the covers, is really quite different. And so we see them as serving different purposes, and the end-to-end testing in particular is very helpful for testing speech recognition and slot matching. And absolutely, you can get a recording for those webinars. Within my presentation, on the last slide, we have a link to our YouTube channel where you can see that webinar. So more questions? What else can we tell you? We do have a webinar for monitoring. Yep, absolutely. That was our last webinar. That was last month. And so that goes through that in detail. You know, and I should say, you know, when we talk about monitoring and, you know, we also refer to it as continuous testing, we try to take the same approach there. So we're leveraging the same sort of tools. It's just at a different stage in the life cycle. Yes, Bo, thanks for mentioning that. We have the poll section. Please do fill that out. That's useful information for us. And any more questions? Certainly happy to talk about any of the things that we went through. We did cover a lot. Hopefully it's not at all overwhelming. We do try to make this very easy to get started with. And we think you'll find it very helpful. So we're almost at the end. I should also mention we'll be doing another webinar next month. That one is actually going to be a joint webinar that we're doing with Applause, which does crowdsource testing. We're really excited to present with them and to talk about what we see as a complete approach to quality assurance for voice and for Alexa. So please do join us for that. I think it's really great subject matter that we're going through. And part of what we'll cover there is actually the end-to-end testing that I mentioned today. So if you're interested in that, it'll also be a good opportunity to learn there. We haven't posted the sign-up link yet, Claire, but we will soon. We'll definitely let you know about when it is. It's tentatively scheduled, I think, for July 18th. And the sign-up should be available soon, like I mentioned. All right, so with that, I think we'll wrap up. Thank you very much for joining us. I hope this was helpful. And yeah, I mean, we will send the slides as well as the presentation as a follow-up. And yeah, just reach out. I think my email and my Twitter is in there. So if you have any questions at all, if you want to talk about this, please just reach out. We love to talk about testing and automation. So thanks a lot for joining us, and have a great day.